Alright, here is part 2 of the notes for lesson 1.3, picking up where we left off. We are trying to find the slope-intercept form of a line that passes through that point and is parallel to this line that they're giving us. And so I'm going to first put the line they give us into slope-intercept form so I can figure out what my slope has to be. If I move over the 2x, I get negative 3y equals negative 2x plus 5 from subtracting 2x on both sides, and then I can divide both sides by negative 3, and I end up getting y being equal to, for the equation here, 2/3 x. It's a positive 2/3 because negative 2/3 divided by negative 3 makes it a positive, and then that is minus 5/3. Now that is the equation. That's that line that they give us, and since we're looking for a line parallel to that, we're going to use that same slope, which happens to be 2/3. So the slope of the line that we want to use is going to be, or the slope that we want for our line is also going to be 2/3. Alright, now we have a point, we have a slope, and so we want to use point slope form. Y minus y1 equals m x minus x1. We have y minus our point, which is negative 1. M, our slope, is 2/3 because our line parallel to it had a slope of 2/3, and if we want parallel lines, they need to have the same slope. X minus x1, and x1 is going to be 2. And I start to work this out here. I get, this is y plus 1, 2 negatives make a positive. I distribute this in, you get 2/3 x, and then 2/3 times a negative 2 gives me negative 4/3. I subtract 1 to both sides here. That is y equals 2/3 x. Now 4/3, negative 4/3 minus a 1, that's the same thing as minus 3/3 because we need that common denominator, which gives me a minus 1/3. Oh, sorry, that would be adding. I'd be adding. That is actually going to be minus 7/3. Going to be our final answer right here. If you want further explanation about how you kind of subtract these here, maybe you kind of forget, just email me and I'll make an extra video. Again, really what I did was negative 4/3 minus 1, and I just changed 1 into 3/3 so I had common denominators and could subtract there. Alright, same kind of problem, but instead of parallel we have perpendicular. So instead of using the same slope like we did with parallel, we're going to have to use the opposite reciprocal. But luckily enough that we have the same line as before, so that again is going to be y equals a negative 2/3 x plus, sorry, I think it's minus, let me check again on this last problem. Yeah, minus 5/3. Oh, sorry, I screwed that up. Let's just look at what we did the first time, because we're using that same line. So it is y equals 2/3 x minus 5/3. That's the line again, but we want something that's perpendicular that passes through that point now. And so if our original slope was 2/3, the opposite reciprocal is going to be negative 3/2. And then again, we're going to have to use point slope form, which is y minus y1 equals x minus x1. Our y1 and x1, I believe, are the same as the last problem again, so that's y minus a negative 1. M this time, though, is going to be negative 3/2 x, and then our x1 is also going to be 2 like it was in the last problem. Okay, just changing things around. That's y plus 1, 2 negatives, distributing it in. It's actually kind of nice this time. That's a negative 3/2x. Multiplying in here, negative 3/2 times a negative 2. The 2's are really going to cancel out here, and we're going to be left with, and their negatives are going to cancel as well, so I think that's just going to be plus 3. Negative canceled there, and that plus 3 was right. And so last thing we got to do is subtract over 1, and we have our equation y equals negative 3/2x plus 2 is a line that is perpendicular to our line, our original line, that passes through the correct point, and a big telltale sign that it's perpendicular is seeing that opposite reciprocal slope. Okay, moving along, again, that one's a little bit more challenging. If you want to see a further explanation, just let me know. Here we have, there's these ratios versus rates. A ratio would be something that would use like the same units. So like pounds and pounds, where a rate would be something with different units. A rate is like miles per hour. That's different units. Different. I think I spelled that wrong. I don't even think I did spell it wrong. I just panicked and had to go check. But different units. My brain's just not working. So different units, same units. A rate could be like miles per hour, where a ratio could be like pounds over pounds or something. Something where we're comparing the same units there. All right, moving into the final stretch, we have a couple of word problems. And so we have a college purchasing exercise equipment for the new fitness center. It has a useful life of 8 years. And the salvage value at the end of the 8 years is $2,000. We want to write a linear description of this situation. So really what we have is 2 points here. When it's brand new, that's year 0. And so we can say that it is on year 0, it is worth $12,000. That would be like my first point. My second point could be on year 8. Year 8, we have $2,000 in value. And then we just want to write a linear equation similar to a problem we did earlier, if I can find it. I believe it's this one here, where we had just 2 points and we needed to create a linear equation. That's what we're doing here. So first thing we need to do is find the slope. Slope is going to be y2 minus y1, so 2,000 minus 12,000 over your change in your x, so x2, 8 minus 0. We have, that's going to be negative 10,000 over 8, which should reduce down to a really nice negative 1,250 over 1, or just a slope that is negative 1,250. Now, using slope-intercept form, we get y minus y1 equals mx minus x1. You can see how many times I've done that through this lesson. It's just really crucial throughout the whole thing. We can do y minus y1, which I'm going to choose the easier one, which I believe to be the 0, 12,000. So y minus 12,000 equals my slope, negative 1,250, x minus x1, and I like that one because then my x1 is 0. Working the rest of it through, distributing that in and moving that over, my final is going to be y is equal to negative 1,250x plus 12,000. It's my final answer of a linear equation that would represent this change in money over the course of 8 years. It's, to me, there's some things that stand out. The negative slope always tells me that I am going to be decreasing money every year, because X is my year, Y would kind of be my output of money. And that 12,000 kind of tells me at first, you know, when year 0 happens, we're there, but every year that goes by, we're going to decrease from that 12,000. All right, last one, same kind of thing. We have to write a linear equation given these 2 points, and we need to then use that linear equation to predict what would happen in 2010. I'm going to use 6 as representing 2006 and 7 representing 2007. So in year 6, we had 35.9 billion. In year 7, we had $40 billion, and I'm not even putting billion in, I'm just using that. And this is going to have to require a little bit of calculator work. But again, I need to find a slope. And so I need to do y2, which is 40 minus 35.9 over 7 minus 6. Using my calculator, 40 minus 35.9 gives me 4.1 over 1. And so my slope m is equal to 4.1. I need to use my slope, my point slope form, y minus y1 equals m, x minus x1. Doesn't really matter what point you choose. I will choose this one because 40 is nice. And I will do y minus 40, which again represents 40 billion. We know my m, sorry, is 4.1. 1, x minus my x1, which in this case, x1 is 7. We'll keep this on the side here. We'll distribute this in. So that's 4.1x. And then I got to use my calculator here. 4.1 times 7. Negative 7 technically would be negative 28.7. And then adding 40 to both sides gives me y equal to 4.1x plus, and I got to do my calculator, negative 28.7 plus 40 is 11.3. And I have my equation. Now I haven't gotten to my final answer yet because I need to plug in x equal to 10 for 2010 because x equal to 6 was 2006, x equal to 7 was 2007, so x equal to 10 is 2010. So I'm plugging in 10 here to figure out what I'm going to get as an output in money. And so y equals 4.1 times 10 plus 11.3. That gives me y equal to 4.1 times 10 is 41, just moving the decimal, plus 11.3. Making sure I didn't screw anything up. I don't think I did. That will give me y equal to $52.3 billion. Put a billion there, or some dollar sign there. And we have my answer. So a word problem, yes, but once you can, the hardest part is probably making your actual coordinates here with the 6 and the 35.9 and the 7 and the 40. Once you again have the 2 points, it begins to look like a problem that we've done before. If you have any confusion on where I'm getting those numbers or how 6 and 7 can work there, or anything throughout this lesson that really has you kind of thrown off, just email me and let me know, and I'm happy, especially because today is Wednesday. I have some free time that we can meet. Remember today, if you are watching this video before our meeting, we do have a meeting from 10:30 to 11:30, and so that's a good time to come in and ask questions about any of this or any of the homework problems. Right here at the end, you can pause and take notes on the summary of these equations of a line. We didn't really talk about standard general form because it's just not very useful, but all this other stuff we did talk about throughout the lesson, all important to write down. And if I get my word wall up and running one of these days, I hope to have all these on there. And then lastly, here is the homework for lesson 1.3. It looks like a lot, but again, it is reduced down from what I try to reduce it as much as I can while still having us practice what we need to practice. And lastly, the one thing I do need to apologize, I don't have graphing paper for you, and some of these problems are going to require graphing paper. You can draw out XY coordinates on your paper if you don't want to buy graphing paper, but I recommend buying graphing paper, or hopefully I'll have some for you next time we meet for class.